All right, so we've got our new piece of paper out. We've cut it out. We put it in our notebooks, except we've switched gears. And I'm going to know that I switched gears, Trent, because the first thing I'm going to do is to look at what type of graph do I have. And now, all of a sudden, I have speed, velocity, time graphs. Now, Peyton, you can't get freaked out on a test if they change speed and call it velocity. You can't raise your hand. Mr. Bullens, the bottom says minutes. I don't know what to do. That's because minutes are time, goober, right? If it says hours or weeks or days, that is amount of time. If the side on the other ones happens to say miles or inches or feet, kids, that's a distance. That's not a speed. If it just has 45 mph, that's miles per hour. That is a speed. They're going to change those things up, but we're paying close attention to that. Now, I'm going to slap some numbers in here real quick because that helps all of us. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Now, we followed the first rule where we determine what type of graph we have. Now it says look at the graph data. Plot if needed. Well, I don't need to plot, but I need to put this into an XY table, don't I? Because that's going to make more sense to me. So my time is X, my speed is Y, so X, Y table. Recording whole screen, I guess. Okay, and if I look at 1, it's at 1. 2 is at 2. 3 is at 3. 4 is at 4. 5 is at 5. 6 is at 6. And it just keeps on going up here. And I notice that it does not really do a lot of changing. Now, if I'm looking at this in the first frame, the one, and then the first X, I'm going 1. But another second or minute or whatever goes by, and now all of a sudden the object is moving 2. Then it's moving 3. Then it's moving 4. If you put a 10 behind that, it was going 10, then 20, then 30, then 40, then 50, then 60, all the way up to 90 miles an hour. What is this object doing if it started at 0, but now it's at 9 or 90 miles an hour, Jeremiah? It is acceleration. It is acceleration. Now, you know that people have misconceptions about this. What are my top 2? Raising your hand. I'm going to do them in red. You know they'll be on the project. What are my top 2 misconceptions about this? Somebody new, Maddie.
Not a hill.
It's not a hill. What's my other misconception, Maggie? It's not what? Not constant speed, because this looks exactly the same, doesn't it? Except for this part, because on a distance time graph, this is constant speed. So this is not constant speed. Boys and girls, these graphs are something you need to work with every day. Every day. I showed the kids in my small groups this morning. You just got to draw them out very quickly. And you have to know them like the back of your hand. Because Zoe, you saw when we were doing that large one. You've got to pick out each little piece in a large, like, complex graph and know what each little one means. So when you see this on a speed time graph, you need to know that it's acceleration. It can't be a question. When you see that line like this slope, and you know that it's acceleration. Okay? And it looks just like constant speed on the other one, on the distance time, but it is not. It's very different, right, Jacob? Very, very different. Who needs more time on this one to write it down? So I can move on? All right, so we're looking at the upper quadrant, right side. number one thing I'm going to do, I'm going to find out what kind of graph I have. And I'll notice I, again, have a speed time graph. Now, for me, Dylan, it's not really easy for me to see this and visualize what's going on unless I put some numbers in there. Time's going to go by, and we'll call it minutes. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Speed, because it's speed, I'm going to say 10 miles an hour, 20, 30, 40, 50, 60, 70, 80, 90, and keeping it real, 100. All right? If I look at this, just looking at it gets me confused because I think the thing's at rest. That's a huge misconception, isn't it? That's our number one misconception. This is not at rest. It looks just like at rest, but it is not. Because if I start to graph out all of the data and put that into an XY table, okay, at 1, it's 40. 2, it's 40. 3, it's 40. 4, it's 40. And 5, it's 40. And all the way across. Every time I look at this object, it's going 40 miles an hour. Call that bottom one hours, not minutes. 40 miles a minute would be really hauling. That's how fast teachers drive on holidays when we're getting ready to go home. 40 miles a minute. I don't think that's possible. That's how fast we want to drive home when it's vacation time. So let's think about this. Deacon, every time I look at this car, it's going 40 miles an hour. To me, it doesn't seem like the speed is changing at all, does it? So what do we call that when the speed doesn't change? This is constant speed. Don't be tricked. This is not a flat road. This is not an object going in a straight line. I could get in my car and go around a track at 40 miles an hour, a circle track, right? It's like boring watching races when they just go in circles. Although they're going like 140, so that makes it a little bit more exciting, right? A little more fun at 140. Does that make sense? I don't think this one's too hard. I think the big thing is identifying the misconceptions. If you identify the misconceptions, Alex, you've really got a really giant step up on all of the problems. If you stop yourself beforehand and say, don't make these mistakes, you're probably going to be pretty good as we move on into it. Okie dokie. Again, sticking with our number one thing that we do before we do anything with a graph. Myra, what should I do? What kind of graph do I have? And I have a speed time graph. And when I see that speed time graph, I look at that and I say, oh, this is easy. This is going back to the starting point. You just taught me that. Boys and girls, this is not. Whoa, can't write in that. Not going to the start. It's not. It's not going downhill. I know it looks like that. I know that people make that misconception very often, but it is not going down a hill. It's not what this is. For some of us, again, it makes a lot of sense, Maddie, when we put these numbers in there so we can see what's going on. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. We're going to put this in speeds of 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Now, Maggie's driving down the road, and when we first clock Maggie, we see that she's going 80 miles an hour. Slow it down. When you look at someone and you see how fast they're going, you clock how fast they're going. So Maggie needs to slow down. Now, Maggie's like, I'm not slowing down. I like going fast. But she looks down the road and she sees a lot of red lights. These are brake lights. And she says, whoa, boy, I better hit the brakes or I'm going to hit the cars in front of me. So when she hits the brakes, her car goes from 80 to 70 to 60 to 50 to 40 to 30 to 20 to 10, all the way down to 0 in about 8 seconds, and she's stuck in Christmas traffic near Concord Mills, which is awful and terrible. Stay away from that place. It's the worst thing ever because the traffic there is awful. At Christmas time, it is the worst place ever. There's way too many cars.
Let me guess how you know that.
Now, I'm watching her speed go from really high all the way down to almost nothing. That's most definitely not going back to the starting point. What do we call that when speed starts to slow down, Jasper? This is deceleration. But Mr. Bullens, I thought you said this was deceleration. On a distance time graph, sure. Not on a speed time graph. This is not a hill. This is not going back to the starting point. This is deceleration. Deceleration. So I'm glad to see, I see people opening up their windows. They're writing all the notes. They're filling out the numbers. Thank you, Meyer. I appreciate that. Thank you, Chris Bell. I appreciate that. I'm glad to see people are taking the time to do that. It's going to make your project really easy when you have all 8 of these, because you're going to have things you can look back at and use them as a guide. And you're going to do a whole lot better than some of the people that I've asked to take notes and I've stared at over and over, and they're still not listening. I can't fix that. And I can't literally, I could come behind you and put my hand on your hand and make you take notes, but I don't think that I'm allowed to do that. That's maybe Grant, I could do that too. That's about it. So, does anybody else need some time on this one? Going once, going twice. All right, I'm going to move on. I'm going to clear annotations. Let's take a look at this last bad boy. This last one I think is pretty easy. I'm going to find out what kind of graph I have. Always. Speed and time graph. I'm going to put in some numbers because it's going to help a lot of you. 0, 1, 2, 3, 4, 5, 6, 7, 8, 10, and 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now, when I look at this, all the way across, as time goes by, who can tell me what my speed is as I go across and plot my data? What is my speed, Jeremiah?
0.
0. Pacey, if I gave you the keys to my car and you went outside in the parking lot and you sat in the driver's seat, put on your seatbelt, grabbed the steering wheel and went 0 miles an hour, how far would you get by the end of the day? Nowhere, because you're going 0. So you're not in motion, are you? So there's this very special term, 2 words that we've used in this class to describe something that's not in motion. What are those 2 words, sir? At rest. At rest. Now, again, we argued in the first class, Mr. Bullens, isn't that also a constant speed because the speed never changes? Okay, if you want to get super technical, yes, I guess, but that's not going to be on the test. Matter of fact, I'm not even sure this will show up because I've never seen this, but if I can find it, I'll put it on there. This one, I've never seen this. This is not even on the chart that I gave you to study, right? But it's a new one, and it's true. Because someone might say, well, I wonder what at rest looks like on a speed time graph. I've seen it on a distance time graph, and it looks like this. At rest. But I know that this, on a speed time, anywhere other than that bottom line is constant speed. Right? Because the speed doesn't change. Technically, this, if you stay at 0, it's a constant speed of 0, but we're not going to get into arguing about that because it's really not a big deal. Questions before I